In this lesson, we're going to be learning how to graph a circle, what equations of circles look like, and find all of the important information and important features about a circle. So let's start off by recognizing that a circle is the set of all points that we consider x, y, that are a fixed distance, called a radius, away from some center or some specified point that we refer to as the center. So no matter where we end up putting this point on the outside of our circle, it's always going to be the same distance away from the center of the circle. So notice that h and k represent an x and a y coordinate on our x and y axis. And of course, x and y also stand for an indicated location on our x and y axis as well. So if we take a look at the diagonal of the distance between hk and xy, we can think of that as the hypotenuse of a right triangle. And no matter where I move that point xy, I can still draw a triangle so that we can see the difference in the x coordinates, or the horizontal distance, and a vertical distance, or the difference in the y coordinates. So if we try to take a look at what the distance is for this triangle horizontally, we should realize that the distance between h and x is just x minus h. Now you can think about why this is the case if you think of numbers. For instance, let's say that h is at 3 and x is at 7. The distance is of course 4 because I'm taking the x value, or the larger value, and subtracting the smaller value. And we could see the same thing for the distance between k and y. The distance is, of course, y minus k. So if we could find what the lengths of these sides are for this triangle, we should be able to apply the Pythagorean theorem, which says to square the legs, add them together, and that should be equal to the hypotenuse squared. So notice that in this case, the horizontal distance is x minus h, the vertical distance is y minus k, so we now know our a and our b values. We can rewrite a squared as x minus h quantity squared. And we could refer to b squared as y minus k quantity squared. Now by the Pythagorean theorem, we know that that equals the hypotenuse squared, but notice that the hypotenuse is our radius. So this is equal to our radius squared. And what we've done is derived the equation of a circle where h and k represent the center, while r, the quantity on the other side of our equal sign, is equal to the radius. And therefore this is the equation of a circle. So let's take a look at an example. Here's an example of a circle. And we know this is a circle because it fits into this form. We could see some quantity of x being squared plus some quantity of y being squared equals some number. So our job is to rewrite x plus 2 quantity squared in the form as x minus h. So why don't we think of x plus 2 as being x minus negative 2? And of course, y minus 1 is the same as just y minus 1. So therefore, our center, which we refer to as hk, is simply the quantity that's being subtracted from x and y, and therefore negative 2, 1. So we can plot that on our graph, and this is the center of our circle. So in order to graph our circle, we just have to find out how far away to plot my points, and that's where we find our radius. Now notice that the right side of the equal sign is supposed to be radius squared. R squared is equal to 12, so we could just take the square root of both sides to find that r equals the square root of 12. Now we should always simplify a square root, so let's break this up into a perfect square to where we have 4 times 3. And now we could take the square root of 4, which is simply 2, and therefore the exact value for the radius is 2 root 3. Notice that the radius won't always be an exact whole number value. But we don't know exactly what 2 root 3 is, to know how far away to plot my points. So we need to come up with an approximation on our calculator so we know that the square root of 12 is approximately 3.5. Well, that means that we can go ahead and move from the center 3.5 units left and right, or rather 2 root 3. And in order to find what these points are, we could just simply subtract 2 root 3 from the x coordinate in order to get a new x coordinate of -2 minus 2 root 3. And we could also add in the x direction 2 root 3 to get -2 plus 2 root 3. Notice for both of these points, the y coordinate stays as 1. But we need to also move 2 root 3 units in either direction vertically, which is approximately 3.5. So we move 3.5 units vertically, 3.5 units down as well. And now we're just simply adding 2 root 3 or subtracting 2 root 3 from the y coordinate, which is why now the y coordinate has changed. Once you have all 4 points, left, right, up, and down from our center, we're ready to draw our circle. So let's take a look at this graph again, or this equation again. And we'd like to now expand this circle, or expand this equation, into what we refer to as general form. Now, general form means there's no parentheses, and that it's equal to 0 on the right side. So this is the general expanded form for any conic section, no matter whether it's a circle, ellipse, hyperbola, or parabola. The only difference is that some of these terms may be disappeared. We have an x squared term, a y squared term, but sometimes we would also have an xy term that we're really not going to be discussing in this lesson, because what this would do is it would cause the graph to tilt or rotate along some diagonal. But a lot of times we would also have a term with only x, only y, and a constant. So let's go ahead and expand this form and see that x plus 2 quantity squared is the same as x squared plus 4x plus 4. When we expand y minus 1 quantity squared, that becomes y squared minus 2y plus 1. And that's still equal to 12, but notice we could subtract 12 to the other side, and now it's equal to 0. Well, this is pretty close to being expanded form, but what we should do is start grouping these terms together so that we write the x squared term first, then the y squared term. Now we move the x and y terms so that we get plus 4x and minus 2y. And the last thing we have is adding a constant. 4 plus 1 minus 12 gives me minus 7. So this form right here is oftentimes the way that an equation would be given. So if we were given an equation that was in general form, and we wanted to find the center and radius, we'd have to somehow figure out how to change from this general form back into the form that tells us what our center and radius are. So the way that we can do that is by completing the square. But we're going to have to complete the square for both the x's and the y's separately. So why don't we start off by grouping together the x squared and 6x term, and then group together the y squared and the negative 12y term. We're also going to have to move this 12 onto the other side, right, or the constant onto the other side. So in this case, we would be subtracting the 29 to get it to the other side. So we can see that this is pretty close to what it should be, but notice at this point we have to complete the square by adding half of 6 squared, which is 3 squared. But now if you take a look at what we just did, we added 9 onto the left side, so we have to compensate by adding 9 onto the right side as well. Let's take a look at y squared minus 12y. We now have to add half of negative 12, which is negative 6 squared. But notice that negative 6 squared is 36. So what we've really done is added 36 onto the left side. So we have to compensate by also adding 36 onto the right side. So now if we combine each of these terms on the right, That gives me a quantity of 16. Now that I've got a quadratic trinomial for x's and a quadratic trinomial for y's, we should be able to factor this quantity on the left into x plus 3 quantity squared. And we can factor this y quantity into y minus 6 quantity squared. And notice that that's now equal to 16. But because the right side demonstrates the radius, 16 represents 4 squared. This is now standard form of our circle, which tells me what my center and radius are. So my center is at -3, +6, and my radius is at 4. So whenever the equation that we're given for a circle is in this standard form, we could easily find the center and the radius. But if it's ever an expanded or general form, this is where we would have to complete the square in order to turn it into a form that tells us the important features.